Hello, and welcome to the DoneJS contributors meeting. Today is Friday, June 2nd, 2017. We have a couple of people on the core team with us today. I'm Chasen. Hello.
Mirror, mirror is not on the wall. This is Justin from Chicago.
I'm Kevin. Hello.
Hey, guys. And joined by a lot of other Batovians who have some cool stuff to talk about and show today. But let's start off with the core team status. Kevin, would you mind going first?
No, I would not mind. So this week we released a patch for CanJS 3.8.2. The main thing that was in that is a memory leak fix that Chris worked on that's in can-stash bindings. And then some other stuff that was added. The equal converter can now take more than 2 arguments, which is cool. And then there was a bunch of bug fixes. Other than that, we've been working on can reflect. So we've got all of the core can libraries using can reflect now. So it's like component, stash bindings. And then can stash and can stash bindings are using observations and reflected values instead of computes, which should increase performance. So next week we'll be looking to release all those can reflect libraries, and we will talk about how we're going to do that later, I think. And then we're going to try to focus a little bit on making it easier to debug CanJS apps using can reflect. And then whatever comes after that, there's a poll on Twitter if you guys want to give your input on what we should work on next. That's it for me.
Cool. Sounds great. Justin.
So I made a the DoneJS Chicago meetup, started organizing them, got that all planned. I'm making a beautiful credit card payment form, which we'll be using Stripe for one of them. And then I'll be doing another one with a simple login, log out form. This means there'll be 2 new recipes. I'll probably have start that like 2 weeks from now. And then I've just been helping people with things. I've done a few issues with Can Connect personally, but mostly I'm just shepherding other people's issues through. And that is it for me. Next week I'm doing a new hire training, so I'll be out.
Cool. Sounds good. And then for myself, this past week, I started off the week working through our Google Analytics and setting up user flows for our site, partly because I should have been doing that anyway, but also we're going to roll out some new changes to canjs.com, and I want to get a feel for how our changes actually impact people getting to the guides and docs and that sort of thing. And I'm working with, I've been working with another Batovian, Austin, on some design changes and the bigger changes to canjs.com. We're super, super close to being done with those. So hopefully we'll deploy those. I'll probably deploy those at the beginning of next week. And then I'll also be working, I have an upgrade blog post, a DoneJS 1.0 upgrade blog post that I need to finish and get out the door. I have some DoneJS and CanJS presentations coming up too that I need to prep for. So that'll be my week next week. Okay, does anyone have anything before we go to topics? Nope. Okay, I think I was the first one who posted earlier this week because I wanted to talk about what our game plan is for committing npm5's package lock JSON files to our repos. I think Chris actually did the legwork on researching things related to that in Greenkeeper and what have you. So Chris, do you want to talk about that?
Yeah, sure.
Thanks.
I mean, this kind of all started because we wanted to know, should we be committing the package log files to our repos, and is that a good thing for us? Justin was really quick to point out that sometimes you don't want to have a package lock because you want the randomness of all of these dependencies that we don't directly depend on, but those dependencies depend on. Those changes you want to be able to detect when you just do an npm install and we're always getting the latest. We want to be able to observe that randomness. And if you add a package lock, when we go to do our CI testing, Travis will use that package file and it won't pick up on that randomness that might be going on in the actual real-time ecosystem. So that's our hesitation to include package lock files. That fact that we won't be able to get that randomness kind of organically as we are committing changes. We won't see those propagate as easily as it is now, where we don't have a log file and there's any new change, it does a fresh npm install and it's always looking at the latest dependencies of the entire graph. So that was our initial concern. Chasen actually found a really cool Greenkeeper tool. I'm going to share my screen because it's better just to put it up there. Can everyone see my screen?
Yep, it's
All right.
me. Yeah.
All right. So here is Greenkeeper has this nice project called Greenkeeper lock file. So basically, whenever Greenkeeper runs its updates for dependencies, it will also follow through with saying, okay, this is a Greenkeeper type PR, and it'll say, okay, at this point, we also want to make sure that your lock file is also on its latest. So that's pretty nice in that we set this up once and we don't have to think about automatically updating as our parent dependencies change. So that keeps things pretty fresh. Of course, there's still the problem of Greenkeeper only really affects the Greenkeeper really only monitors our parent dependencies, not the sub dependencies that they depend on. So we won't get changes about that until one of the parent dependencies bumps their version, in which case then we will get the newer lock file for its subdependencies. So that's a problem because our lock file will at some points be stale. If you just go into the repo and look, it won't always be the freshest. But I'd say that this automated way of dealing with it will cover 99% of our dependency problems in having a lock file. And as I was thinking about this more, it's almost better to have the lock file instead of nothing at all, because the lock file is a source of information. It describes, what our CI tests are actually looking at any given point. And having that committed, we can actually see, okay, this is where things diverged. Like, we have record of that. I think it's more important for us to have the lock file, just even if it didn't do anything, it's a very good timeless artifact of what was actually being built at any time. I know I've tried to go back on some builds that have failed and tried to rerun them, and then they just work. The problem with that is I don't know, was it me or was it the changes that we made, or is it a dependency? Having the lock file inside of source control, it gives us an artifact to make references on. So I think that's why we should start including it, and I wouldn't have a problem starting to add those as we come across repos that need updates. Any questions about that?
Yeah, what's the process then with it? Like, what do we, like, let's say there's a new release of some super deep module.
Mm-hmm.
Like, how do we know about that? And like, how do we make sure our lock file has been updated to incorporate that? Because that's what someone would get when they did a fresh install.
Yeah, so well, first of all, we don't know that already,
We don't know it, but we're exposed to it, because if I just do a fresh npm install, presumably
we're only exposed to it when our builds run, which is the exact same guarantee the log file will give us.
No. I'm exposed to it pretty much every time I develop like something like Can't Connect, because I clear out my node modules and I npm install. So it should get the latest of any available package. So if there's a new patch release, like for some deeply nested dependency, I should just get it.
So
Yeah.
so I think the question is like, when do we update the lock file? Are we gonna, when we're doing what Justin's saying, when we're developing locally, are we gonna delete the lock file and do a fresh npm install every time?
I think so, yeah.
I was expecting Greenkeeper to update that.
Well, it won't update it for sub
Deeply
dependencies.
nested, yeah.
Right. So like if can util, like can param in can util is updated, then we'll eventually do a new release of can util.
But you shouldn't have to. You should not have to release a new can util. Because remember, we pointed everything that we support. We don't hard code dependencies in our sub packages because we want them so that people can kind of
People get the latest.
people can either get the latest or they can specify I want that version, right? Or like what they can do is hard code all their CanJS dependencies, but then they can move some of them. Like, oh, I knew there's this new feature in Can Connect. I want to move to the new patch or feature release, but I want to leave everything else the same, right? But that's why it's important that all of our packages, except for CanJS, allows that flexibility of ranges.
Yeah, so the lock file isn't used for sub-dependencies, so maybe I'm a little bit...
That's what he's proposing, right? Is that like Can Connect would have a lock file.
But when you install Can Connect, it's not looking at Can Util's lock file to...
Yeah, absolutely.
No, it's not, but it has Can Util's dependencies in its lock file. The lock file doesn't just have top-level dependencies.
Correct, but when someone's installing, sorry, I'm having a hard time with this. When someone's installing Can Connect, it's whatever Can Connect's the latest Can Connect's dependencies. It's not going to use Can Connect's lock file.
You're absolutely right.
That's correct. So we have kind of two concerns. We have what are users going to get, and then what are we going to get when we're developing.
Yeah.
So I think we're talking about two different.
Yeah, I'm talking about what we're going to get when we're developing, and I want to make sure that I'm always getting the latest of everything.
Yeah.
I pretty much, when I ever start editing a project, the first thing I do is like I just pull down master, I clear out all my known modules, I do npm install.
Yeah. So what I've been doing for the last couple of days when I've had these lock files locally is just deleting them every time. So it's the same thing: delete known modules and delete the lock file and reinstall. So you end up getting the same thing. It's just an extra step.
Yeah. So, but here's one other consideration. Like, so when we're making PRs, do we necessarily want the side effects of dependency changes to affect our PRs? Like, should we deal with those in separate PRs when dependency issues come up? You know,
I don't think we should. No, I think we shouldn't. I think we should see the side effects are breaking, because we don't want to make that pull request. That means something went wrong. We don't want that pull request to land. If you made a pull request for like Can Connect, but I just made a change in like Can Util that your Can Connect should be able to reference, and I broke your PR, yes, you should see that, and that PR should not land because something underneath has happened.
I don't agree with that, because that PR is not breaking because of his change. So like master would break also because of your Can Util change in that scenario.
Yeah,
it's just that master didn't run. But we
want to know that. Like, it means something it's like useful information. It's like, oh, maybe Can Util's tests are all passing, but I made a Can Util change that was implicitly Can Connect depended on, and now we know, like, hey, something's not working. I want to know that. I don't want it to like have, I mean, an ideal scenario would be if Greenkeeper can just like do all of the combinations of every single possible range and all of the subdependencies and verify those things all work. That would take maybe till the end of time.
Well, but
so I agree with
that, you. Like Greenkeeper will, like, if there's a breaking change in Can Util, then Greenkeeper will open a PR saying this patch release breaks your tests in Can Connect.
Yeah.
So I feel like that's covered already.
I agree with you, Justin, that we do
But
want to know
you
that
shouldn't say
information.
green and merge that pull request.
Why?
I don't know.
That pull request isn't what caused the problem.
Yeah, it's not, but I still feel like we shouldn't. I see that there's still a breaking. Can Connect is still breaking for someone. If someone npm installs Can Connect, and it gets the latest can util or whatever, their Can Connect is broken, and that's
regardless of whether or not we merge that pull request. That's true.
True, but I just feel I guess for me it's just like one of those like I wanna. Like, I like the pain of that because then it's like, go fix your can util. Like, I guess for me, I take that, it's like, to me, what is the benefit of allowing people to merge that? It makes maybe feel good because it's like you merge, you finish your task, and you can pass on the can util problem to somebody else. Like, I don't want that. Like, I want to be like, oh, shit, now I've got to go fix can util so I can get my stuff in. I guess I just want that, like...
Like
reminder.
We don't disagree with that. It's more about separating the two concerns, where one is I need to get this feature in, and the other is there's a dependency problem that we need to work out. And if someone sees that it's blocking their PR, if they make that change, I'd like it better documented that it was a dependency problem than it's like rolled up inside of this feature.
Yeah, I don't like putting that burden on any random contributor, someone that puts in a pull request to fix docs in their test break because of some other dependency thing, and now they have to go track that down. That's not something that they're going to do.
Especially when it's just completely out of our control. I mean, what happens with these dependency breakages is someone is not respecting Semver properly. There's a contract mismatch in how we use someone else's code, which is not necessarily our fault or their fault. It could just be a misunderstanding, but that's separate from the features that we're trying to make. And I think they should be handled differently, just so that we can, at least as far as, PRs go, just to say we're not going to commit a package log file for PRs, that keeps our, our diffs really small to actually see, well, what actually did change, because I feel like if every PR is making a change to this package lock, it's like, well, was that necessary for this change, or was it just a side, it's hard to track down where an issue lies if we just are always on the newest for PRs, in my opinion.
I mean, we should always be on the newest, though. Like that's going to need to be the standard process if we're committing this, which is basically the same thing, is to like delete it, reinstall. You have a new package. You're going to commit that. It's going to have a diff, and you're always going to be like. In some ways, to do this, it's like I almost want. Like, is there tooling that can? Does npm update still? Like, I guess that outdated shows you your things that are outdated, but does that recurse down through your package lock? What's the process right now for saying, give me a new package lock that's like everything to the latest?
I mean, you would just delete it and then reinstall everything.
So you delete your node modules, you delete your package lock, then you rerun npm install, and that gives you a new package lock, and you would commit that.
Or is there an npm up command that upgrades your package lock?
I'm not sure. I know Yarn had it, but I don't know if it would do the same thing in npm. I haven't tried that.
I guess I'm fine with it if we make that like standard practice. I mean, it would be really nice if Travis could then give us like a third build, which is like fine. It's the normal pack. Like it'd be ideally Travis could give us, here's it with the package lock, like for what the person committed. Okay, good, did that pass? Here is another run with everything updated, right? We add to Travis like delete node modules, rerun npm install, and then that way, sure, if we don't want to, like, then we have the information we want. We can say, okay, well, hey, open source contributor, thanks, and we can decide whether to merge it or not. But at least we have that red dot, which is like you have two greens and a red. I would like it if we could maybe experiment with something like that, or they have an easy like move everything to the latest, and we just say best practice. I'm just really concerned about people forgetting to like keep updating your things, and I want to make sure that that is, you know, easy, and we know if a package lock isn't updated to date or something like that.
And my understanding is that's what Greenkeeper lock file does, is it'll submit PRs to update your lock file.
But only for the
That's all.
Greenkeeper PRs, not for our own.
Sorry, what do you mean by that?
So what the tool will do is it'll see if it's a Greenkeeper, like an update to our dependencies PR, and then it will update the lock file. So it's only affecting the Greenkeeper once.
Oh,
And it's only one dependency
Yeah.
deep. It's
Okay.
not like 5 dependencies deep.
okay. I misunderstood. I thought it was like Greenkeeper for lock files, not an additional thing to update Greenkeeper PRs. Sorry.
Yeah, it only covers Greenkeeper PRs, which is you know, not bad, because that's where a lot of the dependency breakage, all of these like uncaught changes will occur, is with the parent dependencies. So it's not a bad thing if we were going to go down this route to have that.
Yeah, I guess I would say that, like, just to move this on, I think it's a fine idea. I guess I would just like, I'd like to see the proposal. Well, if we could figure out the Travis thing and make it run Travis against the like fully updated lock file, that then totally, like, I'm super on board if we can figure that out. And then if not, then just what is the process? Like, we just need to make sure everybody is like NPM up, or if they had that, or whatever it is, just to make sure we should always be developing from the latest set of dependencies.
Mm-hmm.
And then I'm fine with it.
Yeah, I mean, the trade-off is definitely it's a lot more work maintaining a log file, but then we do have that source of information that says where did things go wrong, and we have the full dependency graph. I think that's the most important thing that the log file offers us, because you're right, we always want to be on latest, but when something goes wrong and we're looking through the history, to actually see, okay, these dependencies at this point in time, you know, it's like a snapshot that I think is really valuable to have.
Yeah, I agree. I think that is valuable. In some ways, that's what CanJS tries to provide, is like, here's a snapshot of all dependencies and what their version, and it's certified to work together. And this would be able to bring that down into individual projects, which is nice. I just want to make sure we're gonna minimize like us. I just want us to hit as quick as possible, recognize those problems. So as long as if we have tooling or good process in place to still be getting that, then I agree. I think it's really valuable without any cost then.
All right. Well, this was a good discussion. I'm sure we'll talk about it more behind the scenes, but yeah.
Well, so next steps for this are to just come up with a clear policy of what we're going to tell people to do. Is that correct?
I would say ideally we could see if Travis can do this for us. If we could get a third Travis build that would just always be submitted with the latest lock file. If there's a way to do that with Travis, that's like, then we have kind of everything we need. Because it would kind of warn, I don't know if it's possible to warn people also that there's a mismatch between those, but I don't know. If there's some like automated tooling we could do around that, that would be the biggest win. And then if not, yeah, just get a nice process. Maybe we just add to everything like npm refresh or our own npm run update, and that will delete the lock file and do a fresh install, and we can just run that whenever you check out whenever you're starting on a new project.
There might be something that we could configure in the npm-rc per project that would specify like do a fresh install in development, maybe. I don't know, but we'll definitely check it out. So yeah, that's probably the roadmap we'll look at for that.
And Chris, do you mind continuing to work on this sort of thing, or being responsible for it?
Sure.
Okay, cool.
Yep.
Thanks. Anything else before we move on? Oh, okay. Justin, did you want to talk about releasing can reflect?
Yeah, so I don't know how Brad and Kevin feel about it, but this was there's kind of an issue where we're about to we want to release Can Connect, and to anybody who would like upgrade all versions of things, their app should not break. But the way like Can Stash is written is that it depends on Can Connect having some additional features, right? So you wouldn't be able to use like an old or sorry, did I say Can Connect? Can Compute. So Can Stash depends on Can Compute having these new features. Now, if you tried to use an old version of Can Compute with the new version of Can Stash, it will not work. So is that a breaking change? I don't know. Arguably, right? But we can just bump up, like we can just say Can Stash depends on these versions of Can Compute, right? If it is or isn't, that's one thing to talk about. And then if it is, there is, I think, one thing that we could do with maybe a lot of work or like kind of a hacky thing, which would be we could make Can Reflect, those APIs, know about Can Computes and Can Maps and things like that a little bit. They just would have intrinsic knowledge for maybe this initial release where you say, hey, I want to listen to on value, and you pass it a compute. And even if computes don't have, it can shape duck type that it's a compute it was passed, and then do what Can Compute would be doing anyways. And we could have Can Reflect, and then we could even have something on top of that, like what's it like if Can Reflect is like a mirror, we could have a like funny house mirror version of something of Can Reflect, which would like know a little bit about things and kind of clean stuff up, and then we'd make Can Stash use that until 4.0 or something like that. So I don't know. We could start with, is this a breaking change or not, I guess.
I'd say yes. It's pretty breaking. We've tried to maintain as much compatibility as possible, but I mean, it's definitely obvious that there are places where not having like the reflective symbols on your map type are going to cause a lot of issues. I'm not sure how much it causes in terms of like computes versus like a newfangled observable or some other observable type. But I think that we still maybe have issues where like it might not function correctly if your observable doesn't present as a function, for example. And we also have places where like, I mean, even right now.
By that, present as a function. What do you? I mean, it's like previously was expecting to be a compute function, or is that what you mean? Or?
Yeah. So I mean, like computes are functions when you get to sort of like how they interact with the outside world. So you could count on the things being like function and having like an is computed property that says, hey, I'm a computable function. So we're trying to sort of like stick with that. Or I mean, like for the time being, like we're not trying to completely abstract all of that away because it's sort of hard for us to figure out where everything might happen in terms of that. Like we're trying to squash as much as possible, but there are still places where like some of our existing legacy code may have made assumptions that we're not seeing, and that's that's a potential liability or hazard when moving everything over to just doing like reflecty and being like, okay, on value, get value, set value, and go.
Yeah.
And also, I mean, like some places where like things could be computes and could be like observable maps.
Wait, sorry, Brad, just to interrupt. I guess there shouldn't be any breaking changes if you were to upgrade all your versions at once, right?
Right.
What breaking change would there? Are you saying there might be some, or do you agree with that?
Well, that's the thing. It's like everything that we're unit testing for is fine. Like that's not breaking at all. But we can't necessarily predict the permutations that other people are putting into the system.
Right.
But so there are places where integration testing is still very important, and we haven't gone through that yet. That's part of our like next step to make sure that things are working at a higher level. Like if I poke and prod at this, will the things that are will the things that I assumed about the CanJS system that maybe aren't explicitly stated still true? There are a lot of those, and we can't.
But that doesn't make, to me, that doesn't make a breaking change.
Yeah, you're just saying there's a high probability, well, a higher probability that there's going to be bugs.
Yeah, but we'll go through
them.
that and fix them. I guess to me that's not an argument whether it's a breaking change or not.
I agree. Yeah.
I think what's the argument is like, should someone be able to use like can compute 1.3.0 with can stash whatever we're about to release 3.4 or something like that, which has the Reflect API.
And that's a definite no.
Well, no, they're not going to be, well, unless we do the other thing. But is that a breaking change? Like the way I look at it is like, there's weird ways of looking at it. Is like can connect, like, or sorry, if this was all under CanJS, like CanJS was just one big release, this would definitely not be a breaking change, because to outside observers, there would be no way. Like you use CanJS as a whole anyways. You cannot use different parts of it in the 3.2 world. This isn't a breaking change. This is substantive changes, and we're almost certainly like 3.8 or 3.9, whatever this comes out in, is 3.9.0 is going to be like a dangerous upgrade for a bit, but it will eventually settle down and should be very like we'll work out the kinks. But the fundamental thing is still there. Do we think that can compute 3.0 we should still have like backwards compatibility for which versions of stash, right? Do we want to allow that kind of loose coupling? And then if we make a decision now, does this decision like hurt us later?
It's a decision that we've already made a bunch of times, right? It's like why is the new can util using can param? It couldn't work with the old can param that didn't exist, right? It's like we've done this a lot where internally things require new versions of stuff to exist.
The difference with that example is that it's totally encapsulated. Like the can param, can util. Like if you use can util and under the hood it's using can param, well, that's fine. It's encapsulated. Your external code it isn't changing. Someone can import can compute 3.0 and can stash and pass that old compute to this can stash and might expect them to work together. If something's totally encapsulated under the hood, it doesn't matter as much if like the lower level versions change. It's really when you can like get one thing and get another thing and combine them.
Is that true? How would you pass that compute? Is that a real?
Well, because can stash would load its own versions of computes that it would work from. So you'd have two versions of computes loaded into your app, which you should probably get errors. So I guess I lean towards this isn't really a breaking change because the dependencies should throw errors and things like that and force you to upgrade. I want to know where like the limitations of this are, or just bring this up and
yeah.
So the idea that there are errors that would force you to upgrade, that's a breaking change. So I very strongly lean on the side of this is a breaking change for can stash not to be able to, like newer versions of can stash not to be able to handle.
Those errors have existed forever, just so you know, Chase.
And those errors are totally theoretical in this instance. We haven't actually found a case where you could do that, right? Where you could actually create it.
No. I'm talking about it would load potentially two different versions of can observation, and if you have two different versions of can observation, you get an error thrown. Like that's been around for a while, and there can only be one single can observation.
Yeah, so I think the error that Jason's talking about is like you create a compute yourself and pass it to can stash, a compute with the older version and pass it to can stash. But we haven't actually seen that that's, I don't know if that's even possible. It sounds like maybe it is, but.
I mean, we certainly haven't tried as far as I know. Like,
what do you mean possible?
Opening up other computes and trying to push them into the new can stash in testing or, just.
Oh, it's definitely. I mean, it might not. Hold on, just to make sure I'm understanding what you're saying, Kevin. It would be possible if the can if it was possible to have two versions of can observation load.
Right, which it's not.
Right, which is not.
Yeah.
Okay, so
that's what I mean. Like we'd have to actually test it, actually load two versions of can compute and try to pass the wrong version to stash and see if it actually breaks.
We make that impossible, basically.
We try to, yeah.
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 So the scenario I have in my mind is that if I have a module that is a can compute at a current or old version of can compute, I'm using that in an application where I'm upgrading to the new can stash. Is that can compute not going to work correctly? Is that a scenario that will break?
I think the answer is we don't know.
Wait, what was your scenario again?
Scenario is like I have like a small module that exports a can compute, and I'm using that in a new and that's an old can compute, and I'm using the
because you've specified the old can compute. You've hard coded an old can compute as your dependencies.
Sure.
Okay, and you've specified the new can compute.
And then in my application, I'm using, like, maybe I don't even have control of that module. And in my application, I'm upgrading to new versions of can stash, can compute, whatever. And when I try and, like, if I use that module that's on an old version of can compute, is that not going to work now?
No, but it would never work. Like, meaning that even without this whole big can reflect change, if we made one change in can observation, like added a new feature, released a patch release, and that thing was hard coded at something that was eventually going to load that version of can observations patch release, and then this new your app try to upgrade to a new version of can observation, they're never going to work because you can only have one can observation.
Yeah.
So like that is
would
limit. I
can
mean,
computes have a like from a legacy version be able to use the current can observation if you manually pointed your node modules at it and didn't try to work with it. Okay.
The new can compute is going to have the new can observation as its dependency.
But that wasn't yes, but what about the old can compute?
So the new version of can observation is going to be the only one that your app can load without throwing an error.
So there can only be one can observation. Just like, let's just call it with can observation. Don't worry about can compute. Just say can observation, right? You can only have one version of can observation at one time, right? But the problem though is that, of course, people could hard code they can make a bit tabs that uses can observation directly, a specified version, and then your app could have a different version of can observation. Those two things will never work. And I guess what I'm saying, Chasen, is if like the line of thinking is like that's a breaking change, then we can never ever make new releases of can observation, even patch releases, without saying it's a breaking change for everything else that might import them. So I don't know if that's like, that would be really handcuffing ourselves. And I think kind of unnecessarily, because it like the APIs are the same. We're not breaking anything. It's just people are hard coding versions and things below.
Yeah, this is hard because like I feel like one of the main purposes of breaking everything up was so that you could piecemeal upgrade things that you wanted to if you needed to.
Yeah.
So saying we're introducing like instability and breaking changes in these minor releases, or what feels like breaking changes. I know it sucks.
Yeah, I mean, I think the only way that we can do this is to avoid making I guess what I'm saying is the only fix to this would be to make things like can namespace that are it's really where these stateful things come into place. Like can observation has its stack and things like that. You can only ever have one of them, and you can never ever even make improvements or fixes to the APIs. Right, so it's like
which I realize that like that's not realistic.
That's impractical,
that, so.
Right?
Yeah.
That's I guess what I'm saying. Like because that, I think what we need. I don't know what we I think we need a way of addressing this without saying it's a breaking change. It's like, in some ways, what these things, it's like what you almost want is nothing loads these things directly. They load like some other thing on top that points at these things. And because that thing could, it's almost like you could have a can observation 3.000 or whatever that really just points at like this other can observation, then that thing can change and change and change, but this never changes and everything can just point at that. And the only way this thing changes if like the fundamental APIs of this other thing change. I don't know, that's a way you might be able to like fix it to make it, I don't know.
Yeah, and that's related, like what I was hearing from you before about like if this is a breaking change, then do we need to make a compatibility layer or whatever? Like it seems like that is the thing that we should do while we're still in CanJS 3 and then drop that in CanJS 4.
Yeah, but a compatibility layer still doesn't help solve the other problem that you were just talking about, though, because you still can only load one can observation. So that's still there. Now it lets you use, like, if you can have if your different versions of compute could somehow like, which it may or may, I don't think our version, it would help the scenario where there was a version of can compute, the old version of can compute could still use the new version, which I guess it might be able to, but
that was my counterfactual in the first place. Like if having one can observation, but two versions of can compute, one that's been reflectified and one that hasn't, I think we'd actually run into problems because at least as can reflect is implemented right now, the type inference considers functions to be map-like. And we're looking for places, like we have can compute explicitly reporting that it's not map-like to avoid that in cases where we were like, well, are you a map or are you a value? And that's, I mean, like that's one place where essentially like stash and stash bindings just wouldn't work.
No, but you can make that work, right? Because you can just do, what you do is you basically have the exact same logic. You just duck type that it's compute inside, like, you make can reflect funny mirror, and if that's passed a compute for is map like, it returns false. If it's passed like on value, it knows because it's a compute, even though it's not reflected compute, it knows. Basically, we'd have to make like the logic for all of the kind of the well-known types. We'd have to make a kind of funny version of can reflect that if it's past those things, it can duck type and then provide the right values. And then if it doesn't duck type and find the right values, then it's going to go down into can reflect.
Okay, there's your compatibility layer, I think.
Yeah, except it doesn't work, right? Because the can observation is going to throw an error.
Yeah, because can observation is going to prevent this, and any other kind of similarly stateful things are going to like freak out about it anyways. So that's kind of the, I don't know, that's kind of the issue.
So yeah, so the question really is just, are we okay with this? That if somebody wants to upgrade to the new stash, they also have to upgrade stash bindings, map, list, define map, can compute, all these other things, can component, all the things that we've updated, or do we want to go 4.0?
I think 4.0 is the right thing to do.
Same. I think it's what we need to do to stick to our core value of stability, right?
But then again, are you going to go 4.0, 5.0 every time we make a new can observation? Like, are we
I think it's just, yeah, I mean that. Yeah.
Perhaps, yeah. I mean, I think we need to battle harden can observation as much as we can now, so that we don't have to get to that point where so when we're not making all these minor changes to can observation because we realize, like in retrospect, oh, we should have done this differently, or there's a way that we could have done this better.
It's always going to happen though. Like you're never going to battle harden anything to the point where there's no changes, right? Like can observation is part of a code base that stretches back like 6 years. Like it's nothing is ever good enough, right? There's always gonna be changes. I don't know. I guess the way that I look at it is like the reservation I have about 4.0 is this fundamentally isn't going to change anybody's app, right? Like this shouldn't change anybody's app. It's big performance improvements. No external APIs are really going to change. Only if you're doing funny stuff with like versions. But if we go down that road, then we're always going to have to make new releases. So we could say like, hey, we're going to, and then again, none of the individual APIs are changing. It's just the assumptions on what might be passed to you and what you need to work from has changed. I don't know. I just feel like my personal, what I would do, what I would do is I would like to release it as a 3.9 or 3.10, and then if people actually report problems, like then we fix them, and then there are no problems, and we're still compatible. I guess if people really reported like, hey, this version, I was really wanting to use this old version, and I wanted to be able to pass this compute too, then we can make the compatibility layer. But I would bet that nobody would ever encounter that. I don't know, it's like a practical consideration. And it's just also putting up the 4.0 puts up roadblocks for people. Like, it's just like people aren't going to be as wanting to upgrade, even though there's no reason not to upgrade.
Yeah. So if we go if we do minor releases for all of these, people are going to get them in their apps automatically. If we go 4.0, people aren't going to upgrade to it.
For
some people.
Years. For years, right?
Yeah.
I guess it's like, what do we want to do for majors? Like, I guess it's like the difference between 2.0 and 3.0 is vast. It requires all these code changes. This would require no code changes. And it's like, what kind of signals do we want to send? Do we want to start, what if we do have a release that has code changes for people, that demands code changes? I don't know, that's why it's like in some ways Sumver needs like a fourth number, which is like the degree of which, are you having to use code mods, or you just like upgrade your dependencies and then you're done and everything still works?
I think we should stop talking about this, and the core team should vote on it on Monday or something when we have more than 3 people.
All right.
Agreed.
Yeah.
I would just like to add one minor thing. Like, I know that our users aren't going to really experience that many changes because of this. The one thing that does concern me, though, is like we're trying to do a lot of the reflection and symbology because of a desire for greater compatibility with things coming in from the outside, other view model styles, other observable types, other rendering engines. And I think it would actually be easier on everybody who's trying to contribute these things if they could just say, here's our shim for CanJS 4. And it would be known to work, because then they don't have to say like which minor point release it works with, and then it's just one number rather than 2.
I mean,
that's where, I mean, it's not a breaking change, but it's a brand new feature that people can take advantage of if they need to, that just isn't in other 3.x up until what would be, I guess, 3.9.
That's what minor releases are. There's new features you can take advantage of.
Yeah.
All right.
It's a hairy. It's like, I guess I should just say for everybody, like there's definitely both sides to this issue. I don't know.
We already did this, right? We had a minor release of Can Observation in February, and nobody noticed. So like we already had the same problem where you had to upgrade all your versions at once.
Yeah, it wasn't really fun for package maintaining, but I mean, I think that it's testament to our system working as intended that we didn't really get any sort of note from users. It's like, oh, observation doesn't work.
No, I mean, everyone's using carrots. They just delete their node modules and install, and they have all the latest ones.
Well, no, people should be specifying versions, I think, in their package.json. Like, I don't think they should be, like, if you're in an app, huh?
But they're not. I mean,
I hope they are.
Now they will be with package lock.
Yeah, I mean that's what the idea behind this page in some ways was, so that people can just like, hey, there's a new. I mean, part of it is for CanJS as a whole. The idea is like you have your version, and if you like, hey, I want to move to 3.8, then and I just have the core stuff. I just come here, I copy and I paste it, and then I'm done. And then there would be a 3.9, and they're like, oh, I want to use all the things that work nicely together. I'm just gonna just paste that. And then if like, oh, can component new version came out 3.1, I can copy and paste that, and I'll leave everything else the same. This is just a little bit going to be a different one because like you're pretty much going to need all of these, not all of the observable-ish ones for sure.
So then we need to actually do that in the DoneJS generator, because that's not what it does, right? It installs with caret versions.
Yeah, well, I think we brought that up in another. I said that's fine. The DoneJS generator can do. I think it's all right for it to do hard-coded versions.
But that would be impossible to maintain, right? Because we have to manually update it ourselves.
Why? You can. What do you mean? The generator can figure out the last versions of these things, right? Oh, you mean? Yeah, I mean, okay. I get.
We have to rewrite it. Yeah, it could. It doesn't do that now. Now it's just in there.
Yeah. Well, there's package lock now, so.
All right.
I don't know.
Let's move on.
Okay.
So I think the next topic was from Nils. Yeah. Okay. Nils, do you want to talk about Can Connect behavior ordering and bundling?
Yeah. So this is something I've been working on for the last week or so, and I had some discussions with Justin about it. Let me share my screen. I have a set of notes here that'll be useful.
Cool.
Yeah, so these are just some notes about what we have talked about doing, and to make Can Connect a little bit easier to use, you don't have to know about how every individual behavior interacts with its dependencies. We're going to create some behavior bundles, and those would be sets of behaviors that would implement common functionality that you probably want to add all together. And you could add them to an existing connection, and they would figure out where in that connection they would have to be added. So yeah, they would add multiple behaviors at once, and they would add their dependencies as required. So talking about how that would work, I'm a bit concerned that adding these behaviors will be complicated because a particular behavior might not just, like what we have right now, I'm not sure if I talked about this last week or the week before last in the contributors meeting, or if it was even in the contributors meeting. We've added some interface checking to the Can Connect behaviors so that they check for the presence of particular properties. And that's originally how we thought we were going to do this automatic ordering. We're like, okay, this behavior depends on these properties, and this other behavior offers those properties. So we're going to order them accordingly so that has its dependencies already in the connection when it's being added. However, I'm not sure if that'll be enough because we have behaviors that add the same properties as another behavior. They're changing the functionality of an existing behavior. The example I have is real-time needs to have the constructor callbacks once. So it needs the instance callbacks, which are what are added by callbacks once, but they're also, the instance callbacks are also added by the constructor/constructor behavior. Both of them have these properties implemented. They have these callbacks implemented, but callbacks once works differently. It only will call the callbacks once for a given instance. So it's a slightly different behavior, and it's necessary for real time to work. And by just looking at the properties that are already on a connection, you don't really know, is this the implementation of the callbacks that I need for real time to work? And if you're trying to order real time into a connection and you're just kind of scanning through the behaviors and you find, okay, the callbacks are implemented at this point, is it safe for me to add real time in front of that, or do we?
Real quick about like callbacks once isn't totally needed for real time. It's only needed if your RESTful service is being used as a return channel. If your real time is pushing out events that you already know about, then it's only needed. So meaning like it's kind of a common problem for real time, and I'm sure there's tests in real time to test for this, but maybe those shouldn't be there, and maybe there should be like a more real time. But like let's say I created a new to-do, you could set the server up so it doesn't actually push that new to-do back to me, and so that just comes as part of the response for when the to-do is created. I've done that before, and if you do that, then the callback once isn't needed, and your setup and server would work perfectly. It's only needed for this like situation, which does happen fairly commonly, where the server is pushing to you the same events that you already know because of your return response on what you did as a user.
Right. But like you said, that's a situation that you might encounter, and this is a description of a general problem. Like if we would probably want our kind of behavior bundle that adds real time to also add callbacks once, right?
I guess I'm not as certain about that, because to me it's like you don't necessarily need callback once. You could write your server so it was a little bit smarter and not sending information that you already knew about.
Okay, but we know that there's this potential for an issue and we have this fix for it. Wouldn't we want to kind of preemptively solve that issue if we could, just to avoid our users having to know about this edge case? Like it seems as a user-friendly thing, we would probably want to add callback.
Yeah, maybe then it belongs in real time then.
Potentially. So I'm not sure if callbacks once is a dependency of any other behaviors we have. But like this is still kind of just an example of a general issue. Like this could arise, the same situation could arise with other behaviors, right? Where you have some implementation of some property that you need to have a specific implementation of it. You don't just want any implementation of whatever function. You need that implementation as implemented by a specific behavior. So like this was just an example. So maybe this example is not applicable like you mentioned. But this still could be an issue for our automatic ordering. To get around that, I think that we may have to make our automatic ordering also work not just on properties, but have like some actual naming along with it, saying like, I don't want just someone who implements these functions. I want someone who implements these functions and calls themselves or calls their interface this name. They also say that they offer these properties, they offer these functions, and they refer to it by this name. That at least means that I know that they're offering the contract that I need, right? Something more specific than just having the set of properties available. I'm thinking ahead, like I haven't actually run into this yet, but as I continue with this implementation, I think that we might run into this in some other cases. So we may have to have some sort of actual naming that's attached to these interfaces. So we know that you're offering these properties and you're basically assuring me that these properties have some sort of terminology attached to them that promises me this specific contract, that they're implemented in a particular way. If someone can think up a better name or a better way other than just adding a name to it along with these properties, then I'm open to that. Maybe it'll work.
Brett has brought this up before, and this is kind of what I've wanted to avoid at all costs or all possibility, because then it creates a much tighter coupling where like real time has to know about callback once, where there could be, the way I implemented callback once is kind of terrible. There's probably much better ways of implementing callback once. And yeah, you could give that a name, but it just feels, I don't know, it feels odd to be giving these things names.
So maybe this is something we'll talk about more at a future date if nobody has ideas right now. I just wanted to say that like this is something I'm kind of foreseeing. And I'll bring it up again next week if I run into it during my implementation. So if
I mean, you can see if, yeah. I guess I don't know. The hard part is like, let's just say there was something like, in some ways, the problem is the transparent behaviors. What I mean by transparent is like they are consuming the exact same interface they are providing, and somehow they're doing something. Like, what are they doing that cannot be identified through their methods? You know, what is that conceptually, and how do you label it as with this kind of interface idea?
And I'm also thinking, like, if someone decides to rewrite one of our behaviors and like, replace an existing behavior in their behavior chain, and then we do automatic ordering after that point, how do we know that, like, that's the contract that we need? Like, this naming would also be useful there. Like, if someone rewrites constructor, it's not just that it offers the constructor interface. It's that we know that it's the constructor interface with the contract that we need.
I guess, what do you mean? Shouldn't ordering, because constructor depends on certain things and provides other things, shouldn't you be able to figure out for the most part where that belongs?
Hopefully, yeah. I'm wondering if we run into another situation like the situation here, like if somebody rewrote callbacks once, that's like they would say, well, we're not the constructor interface or instance callbacks. We have written our own implementation of the callbacks once callbacks.
Yeah, but I guess I don't know why callback once wouldn't be able to be automatically ordered in the right place, because that consumes things and then provides other things on top of it. So it would naturally go on top of a provider for the callbacks, and then something else that needs that would go on top of it.
Right. So then we start ordering in real time. Does real time come before or after? Like, because like let's say we're scanning up the prototype chain. Do we put it into the first available like matching position in front of callbacks once, or does it come after callbacks once?
Because it doesn't provide anything. Callback does. I guess I'd have to see it as like real time provide and consume the exact same things that callback once does.
Sorry, say that again. Like, so yeah,
real time consume and provide the exact same things.
Well, real time doesn't know just based off the interface whether or not to come before or after callbacks once.
But callbacks once would know, because it consumes and provides something. So it's like, if it's like saying it provides created data but consumes created data, but real time is saying I need created data, well then it's obvious that the callback once would go in between, right? Because it's like
I'm not sure that's obvious, right? Because both are like callbacks once just says I need a position where I depend on created data.
But it knows what it provides. You need to know the providing stuff too. So because it provides those things, that means it knows it's not the end of it knows it's kind of like a chain of that. So it should go before straight consumers, after straight providers, and it's like a pipe between those things. It knows that it's a linker, so it should always go in between the consumers and the providers.
Isn't there a possibility that there's some behavior that the same way that real time has issues if it doesn't get callbacks once, isn't there a behavior that could have issues if it doesn't get the version of the callbacks that are offered by the constructor as opposed to callbacks once?
It can have an issue, but it should still work. You know what I mean? Like, that's...
Well, don't you want, I mean, ideally you'd be able to avoid that. You'd be able to say there's two versions of these callbacks, one offered by constructor, one offered by callbacks once. Tell me which one you need.
By constructor, one callback.
Because yeah, callbacks once and constructor.
But you don't need, I mean, real time, like I say, only needs callback once. It's optional. It's like, in some ways, the same thing about, what's the parse data? right? Parse data. You only need that if your data doesn't come back right. So parse data is the same kind of thing where it's like, well, if you had the properly like it's where everything works without it, but if you don't have the properly designed system, then you need this additional behaviors kind of spliced in. So I don't think it's the job of the consumer necessarily. I think the consumer should define like what real time. What I would do then say like, hey, I don't know if this needs to solve all problems. I think there should be like real time should basically say, I need this to happen, right? Your created data should only be called once for when data is actually created, right? Not twice as what happens because you have the AJAX response and you're getting pushed, right? So we say that, and by the way, if it is happening twice, and we could even have warnings in real time to say, if this is happening twice, we just saw the same data twice, maybe you should use this additional behavior. I don't think it's real time to like, just like it's not data URL's responsibility or something that might want the parse data. I don't think it's like that thing's responsibility to know where if things aren't complying with what it expects, to say that, to somehow know just because of the behaviors. Instead, it should just probably just be part of docs to say like, hey, if you're having this, this is what this behavior expects, and if it's not being provided, here's maybe some fixes to that. I just don't think it's like a solvable. I don't know. I don't think. I don't know if. I don't know if we can solve all of those things, because it's just like we shouldn't be adding data parse if the data is, and there's no way to tell at the building of the connection.
Right.
I don't know. Let's keep talking about this more, I guess, later.
I get a problem more as I implement it. We'll probably have to talk about it a bit more. Yeah, so anyways, moving on. Like, so the use cases for this is that we'd have these bundles of behaviors. They'd be a little bit easier to configure. They'd make sure that their dependencies are present on the connection. So the bundles that I've kind of conceived of so far would kind of just be, like I've laid out here, a basic data. And that's just, I want to make a connection to a REST API. So it adds URL, it adds callbacks, it adds parse. Parse you may not need unless you actually have to mutate the responses that you're getting. But it's probably nice to have it there just in case. And if you don't implement the methods that parse calls to do that mutation, then it's kind of just a no-op. But it's nice to have it there by default, just as a convenience thing. And then type instantiation. We would do constructor, constructor store, callbacks once, map and merge. So these would all be added at once. Again, kind of, you probably want most of them, and we're trying to abstract away some of the complexity away from our users of having to know, well, I probably need constructor store, and I have to add callbacks once actually might not be in this if it's not actually required for anything other than real time. So I can see that being taken out there. And maybe it seems like from our discussion we might be re-implementing how callbacks once is implemented. And then finally, probably something like caching. These are like the three big behaviors you probably want from your connections. And this one, you have fall through cache, callbacks cache, and then one of the caching implemented added all by a single kind of super behavior. And then the other ones would be real-time, and real-time would add its dependencies, and combine requests, same thing would add its dependencies. Our other behaviors like worker and ref require enough configuration that you should probably be adding those yourself rather than adding them as part of a bundle. But like these combined requests and real-time updating just have dependencies that we could make part of a bundle to make them easier to add. Things like callbacks once. Anybody has some input here, be happy to hear it. If they think that these bundles should be laid out differently, or if there's a bundle that I'm missing.
I think you should. There should be base map. What that all does.
What is currently on base map? Base map is just the data connection and type instantiation, or?
Yeah, for the most part, yeah.
Yeah.
I think it should, but without the merge and things like that, probably too. It should just be like data URL. It should be just data callbacks. Just to answer your question, that's used for all the caching, because what it does is like when anything happens, it'll call like a data callback and all the caching things, or at least like, well, at least I thought it was. I guess maybe it was what callbacks cache does. They all hook into those things. But anyways, the
necessary for constructor store?
Is what?
Isn't the data callbacks necessary for constructor store?
Yeah, probably. I don't remember off the top of my head. But I guess the big thing is like I feel like what most people want to do is just create an easy can map kind of connection with data URL, the constructor, probably maybe not even the constructor store. Just like I think there should be just like a super simple map, which is just like the basic get list, that kind of stuff goes to your URL, almost nothing else, right? And it would be really cool is if you can like then, like, you know, and then there's like the things that you want to add to that, which in some ways, like, I think the things that you want to add to that, I think people can reasonably understand. Like you want to mix in the constructor store, you might want to mix in data parse because your data doesn't look right. I think that's a really nice workflow. And then you want to add real time and you want to add some kind of caching. I think that's just to maybe back up for people who aren't familiar with the conceptual idea that we're going for here. The idea is we're allowing behaviors to add multiple behaviors. So like now what you could do is instead of just like a behavior, like you have to add data callbacks cache, so that if you wanted to add real time, you have to add these like 5 other behaviors in the exact right order that you know about. So what we're trying to do is instead now there's these behaviors that can like insert other behaviors in the right place. So what we can do is now come up with like a more user-friendly set of behaviors that you can kind of call on top of each other in a much easier way. And what Nils is trying to do is figure out what those should be.
Right. So before you just gave that explanation, you were saying that caching should be added by the end user directly, or should it be added through a bundle?
I don't know. I probably a bundle maybe. I think in some ways what we might end up doing is like all of our behaviors, like you don't almost use any of them directly anymore. Like I guess what I think if I were a CanJS user, a normal mainline CanJS user, and maybe there's like versions of this for React or whatever too, but I think if there's just like, you know, like a base can connection or something that you call and you configure it with your options. This is your base can connection. And then, hey, you want to add, you know, data. Ideally, we can add this without having to like do a lot of configuration. But then it's like, hey, you want to add, your data is wrong. Oh no, now you add data parse to your connection. And then you have a new connection. Or maybe the same connection. We have to figure all this stuff out and what's possible. And then like, oh, hey, I don't like, now I've just decided I want real time. And then you wrap it with real time. And you kind of build up, and these things are going to add, like data parse, maybe that's just a normal behavior. It's just a single behavior that you're adding, because I think that's like reasonable and well understood what you need there. But real time, you know, that is not just one behavior, right? That you need to make sure the constructor store is on there. You need to make sure other things. Now, but let's say someone was what wanted the constructor store beforehand. Well, they can add that. And then real time would be able to identify that it's already there and not insert this, like this real time, which is not the low level behavior. Instead, it's like these composite behaviors. And this way, there's just like a little bit nicer of a setup where you don't really have to worry, you know, did you already add the store? Well, that's fine. Real time can see that and deal with that.
Right. I think that you mentioned, going quickly to data parse, Data parse maybe should be a bundle as well, because we're kind of setting up an expectation that these behaviors will add their dependencies wherever possible, like their dependent behaviors. And if we made data parse just an individual behavior, right, it might, if you put it on a connection that's not been configured correctly, it would actually complain about like missing implementation of URL, for example.
Yeah, it would. I mean, I don't. The issue. Well, I guess there's. Do we make all of the user-facing behaviors smart like this?
Yeah.
I mean, is that your?
I think that's the user-friendly way to do it, and then you're offering a consistent interface. You're saying, just worry about the configuration. Don't worry about adding the specific behaviors.
Yeah.
As long as you pass in a connection that has a configuration that would work with data URL, when you add the parse, data URL will be added for you. Okay.
I mean, I could see that. I still think we should have like a separate, like, you know, behaviors, which is like your low-level behaviors.
Yeah.
And then you have your like composites or whatever. And that's like another. There'd be basically data URL there, or what? Maybe not data URL, but there'd be like your real time here. Then there's your real time here. That's gonna like. It's gonna check to make sure this. If you're using this real time, this actually imports like all of the behaviors that real time would have. Make sure they're there or not. You might get waste if you're using your composites. If you're trying to like insert your own, you know, you want your own data callbacks once. You've come up with a better way of doing that. Well, this real time is going to include the default one, so you've got waste there. So if you really need to then drop back, you would not be able to.
So that's something else that could be potentially solved by the naming that I mentioned earlier, is that when you add the real-time composite and you've also added your own implementation of callbacks once, it knows that, okay, you've already done an implementation of callbacks once, I don't need to add this one, right?
Yeah, well, actually, sorry, real-time wouldn't add callbacks once anyways. So it wouldn't do that. I don't think that's a...
But in that sort of situation, we'd be able to resolve that problem if we had that naming.
But there is no problem adding callback once to different implementations of callback once, probably, because they're just solving in different ways. I don't know. I don't think we have to solve. I guess I'm just like, I don't look at it as. I don't think that this is a. I don't think that is going to be a huge issue. I see that as like a secondary, like not a big problem that we need to solve. What I think we need to solve is just easy ways of building up normal behaviors, and making them work. I guess I see what you're saying. I don't know. I need to think about this, Nils. We need to talk about this more later, I think.
I also think it's important for like replacing a behavior. Like if you want to replace a behavior that already exists in the behavior chain, you either need to pass like a reference to the specific behavior object, like in the prototype chain that you're trying to replace. And I guess, I mean, you could expect the users to figure that out. Or you could say, replace constructor in this super map because I've got my own implementation of constructor. Otherwise, you have to determine yourself which, like I said, which instance in the prototype chain you want to replace.
But you would, I guess I just look at it as like, if you had your own constructor, you would make your connection where like you would do my constructor off of some base, and then you could just do super map on top of that connection. And then super map would see that this connection already provides what constructor provides, those interfaces, and would not duplicate it.
I'm wondering if that's possible, or if constructor would just end up ordering itself before that you're my constructor, right?
No, that should be possible because you would see that this is already provided, right? You should be able to see that like this constructor, there's already a constructor implementation on here. We already have that fully satisfied. Do we?
Okay, so
we don't duplicate something that's already been provided.
Isn't that exactly what callbacks once does?
Callbacks once is a low-level behavior.
But it isn't so supermap.
But it consumes things. Like constructor provides things, but it doesn't also turn around and consume those same things. So it's different. It's not like it can't. Constructor is a provider of those APIs. It's providing. It doesn't consume them also. So it's different. It can be identified as different as well. But it does create a problem for there is definitely an issue with how to treat, I don't know what we want to call these behaviors, but like intermediary behaviors, like your kind of middleware behaviors, straight middleware. Like it is not a end and it is not a beginning. It is in between.
Yeah, that's what I'm worried about exactly. So yeah, it's kind of unclear how we're going to handle those right now. Yeah, it's something we'll have to kind of look at. I've given it some thought. I'm not sure if there's a way around other than just giving it kind of a naming. Hopefully there is, but we'll have to talk about it during the implementation of this. So then, yeah, so these are kind of the bundles that we're looking at right now. Maybe we'll have a bundle for each of the more individual low-level behaviors. We'll get this sorted out as I work through the implementation. So then another thing that we've also talked about is some documentation improvements and kind of how we could better ease people into using CanConnect. I think that's something that we're kind of missing compared, like I did some reviews of other technologies, other just kind of front-end HTTP clients to different sorts of endpoints. And one thing we don't really do a good job of for CanConnect is actually giving a guide to using CanConnect kind of as a step-by-step. Here's how you set up your data connection. Let's see how that works. Let's add type instantiation on top of that. Let's see how that works. Caching, and it's kind of step-by-step adding the different layers of CanConnect from most simple to most complicated, different use cases. Our actual API documentation does this, but it's at a pretty cursory level. I'm not sure if it really makes sense to make that a lot more complicated, actually giving like use cases and examples. I think what we really need is guides. And I mean, it could be said that some of our guides show you how to use CanConnect, but again, they kind of dump all the behaviors on you at once. They're kind of like, okay, we're going to set up the connection. We're going to add like the HTTP part of it. We're going to add type instantiation. We're going to add caching all at once. So it doesn't really walk a user through. Like they don't really know which of these they need. And they don't know which one of the behaviors they're adding is really doing what. It's not clear from our guides what behaviors are responsible for what functionality that's being implemented by the connection. So I think that and something that I've seen in these other competing technologies that they have guides that do exactly this. They start you with a simple case and they kind of walk you through adding these other features to it. So I think that probably our top level documentation, we should write some guides for CanConnect. Specifically, not in the context of an application, just in the context of some like demo pages. And those should be kind of what you were shown when you actually navigate to the CanConnect top level docs in our CanJS documentation. All the lower level API docs will still be there, and we'll probably even build like a nice index page for those API docs that shows how the different behaviors typically get ordered to kind of give you a more visual representation of how our behaviors interact. But I still think that we should, for the ease of use of their users, show you, if you just want to get up and running, here's these guides. They'll walk you through the different behaviors you can add.
Nils, I totally agree with you on improving the docs. I love everything that you've put together. We are way over time. Is there anything else that you wanted to talk about specifically that was urgent?
We'll skip over the docs. The other thing is just like this API of actually adding the behaviors. It'll probably end up looking something like this. Whether or not we have a name inside of these behavior objects remains to be seen. But it'll be something like you have a connection. Like these will be inside of what's happening inside of these connection bundles. It'll be doing like a connection.insert, passing a behavior, and then describing where that needs to go in the behavior chain. If anybody has some ideas regarding this, I guess just message me after and we can talk it out.
Yeah, can you open issues, like separate issues for anything specifically that you would like feedback on? And if we can, if you wouldn't mind sharing your notes either in the forums or in a gist or what have you, I'll link to it from.
I'll throw these into a gist, and we actually have an open issue that's related to this, and I'll add it there. So.
Cool. I'll grab those links from you afterwards. Okay. Thank you. And Christopher, Joel, Kevin, I know you guys had topics, and we're obviously way over time. Was there anything urgent before we go? Nope. Okay. You guys can add those as topics for next week if you'd like. Anything else before we go? Nope. Okay, cool. Thank you guys for coming. Everyone who's watching on the live stream, thanks for watching, and we'll see you guys in a week. Bye.
All right, bye.
Bye. Thanks, everyone.